In section 6.4, we're going to continue our discussion about factoring polynomials. And specifically, we're going to look at factoring by grouping, which can be used when polynomials have 4 terms in them, and also factoring trinomials that have a leading coefficient other than 1. Now, I'm going to start by going over factoring by grouping, because that can also be used on trinomials as well, as I'll show you a little later. So whenever you're doing a factoring problem, and your problem has 4 terms like this one does, so you have 2x cubed and then negative 4x squared and then 5x and then negative 10 as your 4 terms, you should probably consider using grouping on that, because that's really the only factoring method that applies to 4 terms. So anytime you're doing a factoring problem and you have 4 terms, it's pretty clear that you want to use factoring by grouping. Now, to do this, you'll group the first 2 terms together and the second 2 terms together. I'll just underline them. And what you want to do is just look at the first 2 terms and find out what the greatest common factor is. So just looking at the 2x cubed and the negative 4x squared, you want to take out the GCF of just those 2. Now obviously the 2 is a GCF because 2 divides evenly into 2 and 4. And for the variables, x cubed and x squared, remember we said that you'd use the smaller power. So your GCF is 2x squared. And so you'll factor that out of just the first 2 terms. And you'll put a set of parentheses. And when you factor 2x squared out of 2x cubed, it leaves you with an x. And then a minus 2 for the second one. Now here's the key thing. Whatever you end up with inside parentheses in this first case here, you want to duplicate that set of parentheses over here on the right hand side, but leave yourself a little blank space before that second set of parentheses. And you then want to figure out what number would you need to multiply right here in front of that second set of parentheses, so that after you did the distributive property, it would come out to be positive 5x minus 10, the expression you have up here above. And the answer would be a positive 5. So you'd put that in with a plus 5. You can't just write 5. You have to write, if it's positive, put a plus in front of it, and if it's negative, put a minus in front of it, because you need some kind of an operation to connect everything together here. Now once you've done that, you now want to consider this to be 2 big terms. This whole thing here is one big huge term, and this whole thing at the end is another big whole term. And what do they have in common? They both have in common the x minus 2. So the x minus 2 that's in parentheses in both of them becomes a common factor, and you can pull that out of both of those 2 big terms. And after you pull that out of the first term, what's left is just the 2x squared, and what's left of the second term is just the plus 5. So the 2 things in front of the parentheses, the 2x squared and the plus 5, get put together to form the second set of parentheses in your answer. And now notice that we have a FOIL multiplication problem down here, which remember is what we're trying to do when we do this kind of factoring, is to write it as a multiplication problem. So this is now factored, and that would be your answer. Okay, let's look at another example. This time, you see we still have 4 terms here. If you can count them, there's 1, 2, 3, and 4. So we'd want to use factoring by grouping. So we'll group the first 2 and the second 2 together. And we have to find the GCF from the first 2 terms. Just these first 2. What can we find in common? And 3 is a common factor because 3 divides into 6 and 9 evenly. And then between x cubed and x squared, we take the smaller power, x squared. So the GCF there would be 3x squared. And if we factor out 3x squared just from those first 2 terms, it will leave us with a 2x in the first case, and then a plus 3 in the second. And remember, we said that whatever you have inside parentheses in this left side, you're going to duplicate that with a little space before it on the right side, because the parentheses have to match in order for grouping to work. And then we want to figure out what do we multiply right here in front of that second set of parentheses, so that if we did this distributive property, it would come out to equal the answer that's above here, negative 2x minus 3. And we'd have to multiply by negative 1. So we'll put it in with a minus 1 this time. And then the factor that's in parentheses on both sides, the 2x plus 3, that's in common to both, can be factored out as one of the sets of parentheses in our answer. And then the two things that are in front, the 3x squared and the minus 1, will be the other set of parentheses. And that would be our final answer. Now that we know how to do factoring by grouping, I'd like to go over how to factor trinomials that are of the form ax squared plus bx plus c. Now in the last section we already talked about how to factor trinomials, but the new thing is that now the trinomial has a coefficient other than 1 in front of the x squared. And that makes the factoring a little bit more difficult than it was in the other case. So the fact that there's a number in front of this x squared in the trinomial tells us that we'll have to do it a little differently. And actually the way I'm going to show you to do this is to use factoring by grouping, the method we just went over. But you might be wondering, if factoring by grouping works only if it has 4 terms, how could we possibly use this on something that has 3 terms? And the answer is that we're going to take the 3 terms and split it up into 4 terms. And the way we're going to do that is we're going to take this middle term, this bx, and we're going to split that up into 2 separate terms. We have to do it a very special way. And once we've split that middle term up, then we'll have 4 terms, and we can finish it out just using grouping every time. Now the important thing for me to show you now is how do you split that middle term up so that grouping will work. So let's look at the example 5x squared plus 13x plus 6. And I'll show you how you can split that middle term 13x up into 2 terms so that grouping will work to finish the problem. Now the first step would be to take your first number, the 5, and multiply it by the constant term, or the last number, the 6. So 5 times 6 would be 30. And usually we do this over on the side somewhere. So 5 times 6 equals 30. So you always take your first number times your last number. And you have to include the signs that are to the left. If they're negative, then you have to use those along with the numbers. So now what we have to do is solve a little puzzle. We have to find 2 numbers, I'm going to use my blanks again, that multiply together to equal this answer that we just got, 30. And those same 2 numbers have to add up to equal the middle coefficient in the problem, which is a positive 13. And so we need to figure out 2 numbers that satisfy both those conditions. They multiply out to 30 and they add up to 13. And you can probably notice that the 2 answers are 10 and 3. So 10 times 3 is 30, and 10 plus 3 is 13. Those are the 2 numbers we're going to use as coefficients to split the middle term. So we'll just put an x after each one. We'll make it a 10x and a 3x. So when we split this middle term up into 2, we're just going to leave the first term alone, the 5x squared, and we're going to replace the 13x with a plus 10x and a plus 3x. And then we'll just bring down the plus 6. Now the nice thing about it is it doesn't matter what order you put those 2 in. So if you wrote plus 3x first and then plus 10x, it would still work. The steps would be a little different, but your final answer will still come out the same. So you can't go wrong with what order you write them down in. Now that we have 4 terms, we'll finish this off using grouping, which we just learned. So we'll group the first 2 and the second 2. We'll find the GCF in the first 2, which would be 5x, and we'll pull that out. And that will leave us with x plus 2. And then we'll leave a little blank space and duplicate that set of parentheses, x plus 2. And then we have to figure out what do we multiply by right there in front of that second set of parentheses, so that when we distribute that through, it will come out to equal a positive 3x plus 6. And the answer is plus 3. So we'll put it in with a plus 3. And then the factor that's in parentheses, x plus 2, on both sides becomes factored out as a common factor, so it just becomes 1. And then the 5x and the plus 3 get put together to form the other set of parentheses. And you've got your answer. Now you can check that by just doing the FOIL. Do the firsts, and then the outers, and then the inners, and then the lasts. And after you combine your like terms together, you should find that your answer is 5x squared plus 13x plus 6. So you can always check your answer to this kind of a problem. Okay, let's try this on another example. So we have 3x squared minus 19x minus 14. And again, we're going to want to split that middle term, but to figure out how to do it, we always start by multiplying the first term, the first coefficient, positive 3, times the constant term, negative 14. So the first and the last, I always say. So 3 times a negative 14. And I'll do this over on the side. So 3 times negative 14 would equal negative 42. So I need to find two numbers that multiply out to equal negative 42, and those same two numbers have to add up to equal this middle coefficient here, negative 19. Notice I'm including the signs on these numbers. Now this one's a little trickier than the last one, but after thinking this through a little bit, you should be able to find that the two numbers that work here would be a negative 21 and a positive 2. Let's just check to make sure they make them both true. Negative 21 times a positive 2 equals negative 42, so that works. And negative 21 plus 2 would be negative 19, so that works as well. So we're going to, again, split this middle term into two. The first term and the last term just get carried straight down. So we'll have 3x squared minus 21x plus 2x minus 14. Okay, so we're using the two numbers we found over here, and we're putting an x after each one when we split that middle term. Now we'll use grouping. So we'll group the first two and the last two. The GCF from the first two terms would be 3, because 3 goes into 3 and 21, and also x. And if we factor 3x out, we're left with x minus 7. We'll leave ourselves a little blank space here, and then we'll repeat that x minus 7. And now we kind of want to multiply backwards. What number do we have to put right here in front of this second set of parentheses so that it would multiply out to equal 2x minus 14? And it's a positive 2 this time, so plus 2. And then our answer would just be x minus 7 times 3x plus 2. Now let's try one that has two variables, a p and a t in this case. We're really going to just do this the same way though. So we'll start by taking the 16 times the negative 2. We'll do this over on the side. So 16 times negative 2 would be negative 32. And then we need to find two numbers that multiply out to equal negative 32. And those same two numbers have to add up to equal this middle coefficient, positive 31. And this one's pretty easy. The answers would be a positive 32 and a negative 1. Because 32 times negative 1 does equal negative 32. And 32 plus a negative 1 would equal 31. So now it's time to split the middle term up into the two separate parts. And we'll rewrite what we have. So we have 16p squared plus 32 pt minus 1 pt minus 2t squared. Okay, now we'll group the first two and the second two. The common factor in the first two would be 16p, and And when we factor that out, we're left with p plus 2t. So we'll leave ourselves a blank space and duplicate that p plus 2t over here on the right side. And now we want to kind of reverse multiply. What do we have to put in front of this parentheses here? So it would multiply out to equal a negative 1 pt minus 2 t squared. And the answer to that is going to be a minus t. So then when we write our final answer, the p plus 2t is going to be one set of parentheses, and the other one is going to be combining the 16p and the minus t together. So 16p minus t. And that'd be our answer. Now I'd like to do a couple problems where we're going to factor completely. Now remember, factoring completely, we talked about in the last section, is the process of factoring it in stages where there's more than one step. The first step would always be to factor out the GCF. So if you can pull a GCF out of all the terms, you do that first. And then assuming that's done, then you'll have a GCF with something after it inside parentheses. You want to try to factor the expression that's inside the parentheses in the second stage. Okay, so for example, let's say we started with this problem. We'd first want to look for a GCF all the way through all three terms. So there's three terms here. What do they have in common? Well, you might start by thinking, does 8 divide in evenly to everything? But 8 does not divide evenly into 50. So, but 2 does. So 2 divides into 8, 2 divides evenly into 40, and 2 also divides evenly into 50. So 2 is a GCF. With the variables, remember, it has to be in every term to be a GCF. So x is in the first two, but it's not in the last one. So you can't say that x is part of the GCF. Y, on the other hand, is in all three terms. So you have to pick the smallest power, which is right here in this first term. So it would just be y. So the GCF would be 2y. And if we factor 2y out of this entire polynomial, we're going to be left with 4x squared for the first term, and then minus 20xy in the middle one, and then plus 25y squared for the third one. Now we want to try to factor this expression that's inside the parentheses. Now since the coefficient in front of the squared term is a 4 and that's not 1, we'll use the procedure we just learned. So we'll take the 4 times the 25 on the side, and we'll multiply them together. So 4 times 25 is 100. So we need to find two numbers that multiply out to equal 100, and that those same two numbers add up to equal the middle coefficient, negative 20. And the two numbers that satisfy this are negative 10 and another negative 10. Because a negative 10 times a negative 10 equals a positive 100, and a negative 10 plus another negative 10 equals negative 20. So we'll split that middle term into a negative 10xy and another minus 10xy. So we're going to split that up. The first and the last one just carry down. So we would have 4x squared minus 10xy minus another 10xy plus 25y squared. Now this 2y, that was the GCF at the beginning, we are going to have to bring that down in front of our final answer at the end. So we won't forget to do that. But for now, I'm not going to write that down. So now we group the first two and the last two, and the GCF in the first two would be 2x, which leaves us with a 2x minus a 5y. And then we want to leave a blank and then write down the 2x minus 5y over here. And then we want to try to think what number would multiply out to equal a negative 10xy plus 25y squared. And it looks like it's going to be a negative 5y. Minus 5y. Works in both cases. So the answer to that second part of the problem that's inside the parentheses would be 2x minus 5y times another 2x minus 5y. And remember, we have to bring this GCF at the beginning down and write it in front of that answer. So we'll go ahead and write that in, 2y, right there. And the only thing else you could do is, since these two sets of parentheses are identical, you could write it once and put it to a power of 2, which is a little bit better way of writing the answer. So you could say 2y times 2x minus 5y in parentheses squared. And that's a little bit more condensed way. Okay, let's look at this next example. We have negative 10x squared minus 8x plus 24. Now when we're finding the GCF, we're looking what's in common. We have a 10, an 8, and a 24. So it looks like 2 divides in evenly to everything. And as far as the variables go, you have an x in the first two terms, but not in the third. So x is not part of the GCF. So it looks like it would just be 2. But remember, we talked about in the last section that when this first term, this what's called a leading term, has a negative coefficient, like this one does, a negative 10, it's really beneficial to not just factor out 2 as the GCF, but a negative 2. So we'll want to factor out that negative number when that first term is negative. So we'll factor out a negative 2 from all three terms. Now when you factor out a negative number, it changes all the signs. So this negative will change to a positive, this negative is going to change to a positive, and this positive will change to a negative. So we're going to have 5x squared plus 4x minus 12. Okay, now that we've done that, we have this trinomial inside the parentheses, and the leading coefficient is a 5. So we'll have to use our new process. So we'll multiply the 5 and the negative 12 together over on the side. So 5 times negative 12 comes out to be negative 60. And then we have to find two numbers that multiply out to equal negative 60, and that also add up to equal 4. And the numbers that make that work are a positive 10 and a negative 6. Because 10 times negative 6 does equal negative 60, and 10 plus negative 6 does equal 4. So we're going to split this middle term up into those two terms, which will give us 5x squared plus 10x minus 6x minus 12. And remember, I'm going to have to bring this GCF down at the end, but I usually don't write it down in every step until I finish the problem. I'll carry it down then. And so I'm going to group the first two and the last two, and the GCF between the first two would be a 5x, which leaves me with x plus 2. Leave a blank space here, put it down another x plus 2, and let's figure out how to fill that blank in. It looks like it would be a negative 6 in this case. That makes that work. So the answer to that part of the problem would be x plus 2 times 5x minus 6. And then we'll just carry this original GCF down and write that in front of our final answer at the end. Try not to forget to do that. And that would be your final factored answer.